Yes, everyone. We are having in 3 more minutes, everyone. Only
Good evening, sir.
yeah. Good evening. Good evening.
Good evening, sir.
Good evening, sir.
Good evening,
Good
Yes.
evening,
sir.
Good
sir.
evening.
Good evening,
Good
sir.
evening.
Good
Good
evening,
evening.
sir.
Good evening,
Good
sir.
Good,
evening, sir.
good evening, everyone.
Good evening, sir.
Everyone, just mute yourself. Just mute yourself. Nice. Yeah. Good evening. Good evening, everyone. We'll wait for only 2 minutes, and then we'll start today's session. Good evening. Good evening, everyone. Good evening. Yeah, everyone. As usual, your rules is going to be same. What do you have to do? Just have your notebook with you, so that you could, if you find anything important, you can just note down that. The second thing is your mic would be off, like the when sir just going to speak about any topic or something like that. Okay. But after that, if you want to ask anything, you have to just raise your hand, and then you can just interact with sir. Is it clear? If it's fine, then just type yes in the chat, everyone. I hope this would be clear. Good evening, everyone. Okay, nice, nice, nice. And one more thing, everyone, just don't focus too much on sending reactions. Let me just off that as well. Yes, it's already off. Just don't send that much reactions. Just don't send that much. Just don't type that much into the chat as well. Just focus on the session. Okay. Okay. I think in 1 minute we'll start that. Session is gonna be good. Yeah, definitely it is gonna be amazing. Risan, if you have been missed the test, just you can just appear it again. Okay. The time have been extended till the 10 p.m. So you can just appear in that. Okay. Okay, everyone. So it's already 7 o'clock. So hello everyone. As you already do know about me, good evening to all of you. Today, this is your scientific talk in which we are having Dr. Uh, basically Dr. Deepak Singh sir. And you do not know about him. Let me just tell you a few things about him. Sir is basically planetary scientist. How many of you do know about that? What is planetary scientist? Do anyone know? Do anyone of you know about that? Okay, yeah. So basically, lots of people already do know about that. What is the planetary scientist, right? So sir is a planetary scientist. Sir has done lots of things. He has lots of experience. He was a student trainee in the ISRO as well. So today you can ask anything to the sir. Sir will be just going to answer you whatever the doubts you are having and all. Okay. Before that, okay, sir is going to take a small session regarding any topic on the astronomy and all. After that, you can just raise your hand, and after taking the name of your, then only you have to just speak. Okay. Before that, no one going to unmute themselves. I hope this would be clear, everyone. Is it fine? Just type yes in the chat if it's clear. Okay, nice, nice, nice. Okay, okay. So without wasting any single minutes, I would like to request to the basically Deepak sir, Deepak Singh sir. Thank you so much, sir, for joining us. Please take over the session, sir. Am I audible, sir?
Yeah, you are audible.
Yeah, yeah. Sir, by the way, these are the Summer School of Space Science student. They are from the grade 5th to the 10th standard students.
Okay. Yeah, I see small kids.
Yeah, yeah. Their mic is off for now, sir. After the session, I'll just unmute them and we can just go. Dashboard. Sir, are you sharing the dashboard?
Yeah, something is playing, right?
Yeah, are you sharing that dashboard, sir?
Or you are sharing the dashboard.
No, 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 I'm not sharing it, sir. Okay. Someone else is doing that. Okay, sir. I'll stop
Someone
it.
else might be sharing it.
Yeah, let me just stop their all activities now. Okay. They can note.
Okay, guys, don't share anything. I have to share.
Okay, sir. Please continue.
Okay. First, let me share the slides. Okay, guys, please stop sharing. Otherwise, I won't be able to share. Okay, so I hope my screen is visible.
Yes, sir.
Okay, let me wait a second. See, if you guys keep on doing this, I won't be able to present. I don't understand like what is happening.
Uh, yeah, sir. I'm extremely sorry. Wait a second, sir. Everyone just stop doing this. Sir, just give me 1 minute. So I'm just closing into all these things. Sharing. I'll just change the settings. So these people are really the captions.
Okay, all good?
Yeah, sir. I think almost done. No one to share anything now.
All right.
Who is drawing this?
I
Everyone
don't
just
know
stop
who's
drawing
going.
this. Sure.
Whatever you are doing, do it on your PC. Don't share. That's all. So my slides are visible.
Yeah, yes, it's visible.
Is it full screen?
Yes, sir. Now it's full screen. Yes.
Okay. Okay, guys. So, is English okay with everyone or Hindi is also okay with everyone? I only know Hindi and English.
English is fine, sir, because whole the class is just going in the English, so maybe English will be better.
Okay, I'll continue in English, but later on, if anyone wants to ask anything in Hindi, that is also fine with me. Okay. So, everyone, again, good evening. Thank you for being here, and I'm very happy to share some ideas and things about universe and us. So, I've kept the topic very simple, um, and I'll try to keep it simple because I know you are young kids, so I'll try not to make it too complicated. But if you have any questions or anything, please keep it for the end. I'll answer, I'll try to answer all of them. Okay. And again, a request, please stop drawing or whatever you are doing. And if you are doing it, please don't share. Okay? Okay. So they are not listening.
Chaya Ravi. Okay, sir. I'm just removing few people, sir. Wait a second. I'm really sorry, sir.
Uh, there must be some setting like you should do, like they should not be able to share. That's it.
Yeah, sir. Just sir, from your side as well, it would be possible. Like when you're sharing it, then you can just do it, sir. Who can just annotate? There will be option for that in
Uh,
the annotation. Is
okay,
there
I
any
did it.
option?
Yes, I did it.
Okay.
So I think now it's
Okay.
gone.
Okay. Everyone just
Okay.
try to draw it now. Are you being able to do that?
I think now they cannot do it.
Okay. Okay.
Good. Thank you. Yeah. Okay. I don't use Zoom that much, so I was not sure like how to fix it.
Yeah, so there is a lots of setting in this. That's why it's
Yes. Okay. Okay. All good. So yeah, if you want to take any notes, you can do it with your hand, and that is the good thing. Write it on paper. Okay. Don't write it on a screen. This writing on a screen is not good. Okay. So let's get started, and then we'll talk more at the end. All right. So I'll start with like where we are, what is this beautiful universe is, and how we come here, like what do we are made up of. So before starting, first we have to understand like how big the sun is. And if you don't know how big the sun is, then within the sun you can fit 1.3 million Earths inside it. So 1 million is like 10 lakhs. So 1.3 million is 13 lakhs. So you can fit 13 lakhs Earth inside one sun. That's how big our sun is. Okay? It looks very small, of course, because it is very, very far away from us. So anything which is further away from us will appear smaller, right? So you already know this. So that's why sun appears is very small. Even it appears almost equal to the size of moon, right? That is why during solar eclipse the moon covers the entire sun, right? But moon is very close to us and sun is very far away from us, and that is the reason the sun appears almost the same size of moon. But actually moon is very, very small. Moon is even smaller than earth, right? So this is the size comparison I'm telling you. But and in our solar system, sun holds about 99.8% of our mass. Okay? So that means if you consider all the planets in our solar system, all the small objects like asteroids, small here and there, comets, all the objects which we have after sun is only 0.2%. So even Jupiter is so big, right? It's so huge, such biggest planet. Still, everything covered within 0.2% only. Sun is like 99.8%. So it's like an anchor, means it is holding the entire solar system together. At the center, sun is there, and all the planets, all these objects are going around the sun because of the gravity of sun, right? But still, sun is just an average star in our universe. Universe is big, right? Universe is like billions of light years big. If you don't know what a light year is amount of distance light travels in 1 year. That's why light year. So light year is a unit of distance. So light travels very fast, 3 into 10 power 8 meters per second, right? So can multiply that with 365 days, then 24 hours, then seconds, just convert everything. You will get a very big distance. So that one big distance is 1 light year. So our universe is many, many billion light years across. Okay, so it's such big. It's so big, right? So within that, our sun is just an average size star as compared to other big stars like UI Scooty, and then I just many, many stars are out there, right? So here is just an image to show you like how stars are like in our universe or in our galaxy. And then what other things are you are seeing here is dust. It is called cosmic dust, okay, or star dust. It is not like our earth dust. Our earth dust is slightly different. This is the dust which has been created by multiple collisions and explosions, and things happened in the universe. So they are made up of different elements and compounds, like carbon and higher heavy elements, right? The stars, they are made up of hydrogen and helium, like our sun also. So sun is, as you know, is mostly hydrogen and little bit of helium. And that helium comes from the fusion of hydrogen into helium, right? So here also in other stars, it's basically made up of hydrogen and then some helium and then some heavier materials like lithium, beryllium, boron, carbon, and all these heavier elements are also there, but in a very, very small amount. And if you consider the entire universe, hydrogen is the most abundant gas in the entire universe. It's like most abundant element. And there is no other element which has higher concentration than hydrogen. So hydrogen has the highest amount in our universe. Okay. So what happens inside these burning stars? There is this immense pressure, very high pressure. It cooks up heavy chemicals, as I told you, like carbon, nitrogen, all these things. So everything starts with hydrogen, and then there are multiple reactions happen, fusion happens, and then they combine together to form these heavier elements like iron, oxygen, carbon, and everything. At the end of the lives of these stars, they explode like fireworks, and they spray this material everywhere, and as I was telling you, it appears like dust, okay, because now it is cooled down and the heavier materials are just floating in space, waiting to be combined together and all that. Something happened. Okay. So that's what happens, and they are called supernovas when they explode and all the energy is released. And then eventually, all the material which you see coming out becomes the part of us and the universe, right? So the whole life which you know, for example, the calcium in our bones or iron in our blood, it's all coming from these exploding stars. Not right now, of course, but when the universe formed and when our solar system formed, at that time, all these materials were floating around, right? And then they combined together. And then when the life originated on Earth, these the things were absorbed or captured by the life and on the Earth. All right. And that's how a life evolved slowly using these different materials, elements, minerals to form this kind of very complex life which we have. So there are few weird planets also. For example, in our solar system, we have one Venus. As you can see, it's a very slow spinning planet, and why it is unique because you can celebrate your birthday 2 times a day on Venus. Why? Because it is a very slow planet, so it takes like 243 days for one spin. So Earth takes, 24 hours, right? We have one day of 24 hours. But on Venus, it is 243 days. It is so slow. And going around Sun, it only takes 225 days. So it completes 1 year before it completes one day. So Venus is a very interesting planet, right? And then in some planets like Neptune and Uranus, the pressure inside the atmosphere, when you go down, it becomes so high that the methane or carbon, it gets compressed like we have on Earth, and it becomes diamond because you need high temperature and high pressure, right? That's how diamonds are formed, from carbon. So on these planets, the pressure and temperatures are so high inside their atmosphere once you go deep down, that the carbon converts to diamond. And since it is in the atmosphere, so it rains diamond there, not water like our Earth. It rains diamonds. So if you can go there, you can actually feel diamonds raining on you, right? So quite interesting objects which we have in our solar system. And it gets more strange as we go further away from our Earth and further away in the universe. How it gets strange? We have black holes. Some of you might have heard about them. Of course, they are not monsters. I have just put it here. The thing with black hole is their gravity is very, very high. So if you try to jump, you cannot escape that gravity, right? You need very high force or energy to escape. That's why we build rockets. And rockets, you put lot of fuel like hydrogen, right? And you burn it. And that high energy, when it rushes out of the rocket, it pushes the rocket up. And that's how rocket can leave our gravity of Earth and go into space, right? So you need a lot of energy and force to do it. But imagine if I make Earth bigger with more mass, then you will need more energy to escape, right? So black holes are objects which are so big and so huge, there is so much mass that even light cannot escape. You know, the speed of light I was just talking about, 3 into 10 power 8 meters per square. So even light has a limit. So the gravity becomes so high that it does not let even light to escape. And that's why they're called black holes. Means they appear black and they're like a hole. Nothing can escape them. And if you or any human or object gets too close to it, what happens? A process called spaghettification. So spaghetti, you might like noodles, right? Spaghetti, if you don't know, it's noodles. So what happens? You become a noodle. Why? Because the force is so high. So for example, if you are like this, so force on your bottom will be very high as compared to the gravitational force on the top, right? Because the gravity cha- changes by 1 by r square. And since near black hole, the gravity is very, very high, so even your length is enough for having very drastic changes in the gravitational force. And because of that, you get stretched like this, and that's why you become like a spaghetti, a noodle, right? So that's what a process happens. But don't worry, don't be scared. Even the nearest black hole which we have is very, very far away, millions of light years away from us. So light year, as I said, is a very long distance, and then millions of light years, so very, very far away from us. So no need to be scared, right? Nothing like that is going to happen. In case you have seen movie Interstellar, there they show this black hole, right? So that's what how the black holes appear. And if I talk about the speed limit, so in our universe, speed of light is the speed limit of cosmos or anything that can happen in our universe. There is nothing that can move faster than light. That is the limit universe has put on us. Why? I don't know. Nobody knows. But that is the limit. Okay. So it takes about 8 minutes for that light to reach from sun to earth, and about 5.5 hours to reach like Pluto, which is the farthest planet, a dwarf planet, I would say. And then 4 years it will take to reach the next star, which is closest star to our solar system, which is Proxima Centauri. Okay, and 100,000 years means 1 lakh years to go from one side of our Milky Way to other side. So Milky Way is our own Milky Way, which is big, right? Big Milky Way galaxy is there. So in that galaxy, we are somewhere in the side. So our solar system is there. And if light wants to go from one end to another end, it is about 100,000 years, 1 lakh years. So that is 100,000 light years big our galaxy is. So you see how huge our galaxy is, right? Okay, so there are some space secrets or space things which is there. One is there is no sound in space because space is silent. Because you all know that sound needs some medium to travel, right? Without medium, sound cannot travel, and space is vacuum. There is no material, the sound cannot travel. But there is a smell. Some astronauts have reported that they smell the space just like a hot metal, burnt steak is meat, or wielding fumes. And that could be due to multiple reasons because a lot of burning is happening in stars and that burnt out material is leftover material is there. So there could be many reasons, okay? And also, if you go in space and gravity of Earth is not squeezing your spinal cord, then what will happen? You will grow taller. So if you want to grow tall, go in space, right? So it is not squeezing your spine, the Earth's gravity. So that's where you get stretched a little bit because your body relaxes, everything that has been pulled down due to gravity, the force is not there, and your body stretches in space. So that's those are a few things, interesting things about space. And then if I talk about mountains, so you know mountains. So you probably know that Mount Everest is the tallest mountain on Earth. Yes, that's true, but that's true if you consider sea level as the measurement reference. But in actual reality, Mauna Kea, it's a small island in Hawaii. Hawaii, it's in Pacific Ocean. So it's a Mauna Kea. It's a mountain which is about 10 kilometers, 10.2 kilometers high. Actually, it's on Earth. And when you measure from its base to the top, but of course, its base lies below sea level. That's why it is not considered the tallest mountain. But just for your information. And then on Mars, we have Olympus Mons. It is the tallest mountain, again, about 22 kilometers. And its size is so big that if you put it on Earth, it will cover like one state of Maharashtra, or almost approximately. So Maharashtra, you see, is a big state. And this one mountain will cover the entire state. It's so huge. Okay. And then on asteroid, this Vesta, there is a peak. It is even 22.5 kilometers. Again, from its base to the top. So we have such huge mountains in our solar system, and we don't even, not many people know about it. So it's very interesting if anyone gets to go there and actually see those mountains, right? And when we go out, what we look for? We look for these Goldilocks zones. What are these Goldilocks zones? The zones or the places, which are also called habitable zones sometimes, are the places around a star like our Earth where the temperatures are not very high or not very low, so that the liquid water can sustain and any life form can also sustain there. Okay, so these are called Goldilocks zones. And in case you want to know more about like aliens and how do we look for different types of life forms outside our solar system, so I have a small video which I made earlier. I'll share that link with you guys in case you want to listen to that. It's like a half-hour discussion with another person. So, but that goes into a little bit of more details. So, in case you're interested, you can watch it. But this is what we are actually looking for. The water near a star like sun, if we can find, or a planet where we have conditions like not too hot, not too cold, and possibly having some life form. Okay. Of course, universe is huge. There are a lot of things to be discovered, a lot of things to be known, and a lot of explorations still needs to be done. We only know a fraction of it. So more and more research are being done on it. And I study mainly planets like our Mars, Moon, Venus, and Europa. Europa is a moon of Jupiter. So I try to study mostly these, and that's why I'm a planetary scientist, not astrophysicist, because astrophysics people, they study these big stars, formation of galaxies, and things which are very, very far away from our solar system. Their movements and all these things. So this is what I do at IIT Bombay. All right. So be curious, keep looking up, means the universe is there. If you are interested, you can become an astronaut, you can become a scientist like me, or you can do research, you can do something else. Like you might have heard yesterday, there was a private rocket launch which happened by a private company, first time in India. So you can become an engineer who build rockets, right? So we are anyways fascinated by universe all the time. So you can do things which can fascinate you and help you understanding this cosmos a little bit more. So that's all from me, I guess. Yeah, thank you so much. So I'll stop here. Thank you for listening. If you have any questions or queries, I think I would be happy to take some questions now.
Sure. Thank you so much, sir. It was really nice session. I hope everyone enjoy that. Everyone just raise your hand. And let me just tell you one more thing before unmuting you. Okay. You all have to just speak when I'm just going to call your name. Okay. Then only you would be able to speak on that. Okay. This is the mandatory type of things. If you're not going to do this, I'll be just going to remove you from this meeting. So just don't try to do anything else. Okay. I hope this would be clear. Okay. Okay, everyone. So I'm just unmuting you. There is a lots of people raising hands.
Okay, class is not over. I just
Yeah.
did a brief introduction so that you guys will understand what I do and what you guys are here for. and now you can ask questions. I'm here for some time, so don't worry. Okay.
Sir, we should just take the question from the chat or like,
Let's
okay, let
ask,
me ask.
let's see what the students have to ask, and then in the chat you can just check like if there is a decent question, you can let me know.
Okay. Okay, the first one is the Vedika. Vedika, just turn on your camera. Vedika Pramod and ask your doubt.
Yes. So, sir, you said that black holes they cannot. There's no light coming out of it. But I actually saw the Stephen Hawking theory. There is a small light that is coming out from the black hole. Sir, you're on mute.
I'm muted. Okay, fine.
No,
Can
it's
you
okay.
hear me now?
Yes, sir.
Okay, so Stephen Hawking, see, understanding Stephen Hawking is very complex here, you know. He was a great scientist. So we have never detected a Hawking's radiation. He talked about Hawking's radiation, but we have never detected it. But what he said is that since black holes absorb so much of energy all the time and material, so there should be some radiation which is coming out from black hole eventually. So that is what his theory was, but we have never detected it actually, because so far the understanding says that nothing can escape black hole, and that's why uh, that is just a theory. Okay, in simple
Okay,
terms.
okay, sir.
Okay. Next one is Muhil. Muhil, please ask your doubt.
Sir, I have 4 questions.
Four
Yes.
questions.
Sir,
Uh, okay, quickly ask them. Try to make them brief.
sir, which star was born recently?
Hey, I am not here for your GK quiz. You ask me some science questions, na? I'll try to answer you. Okay, you
Okay,
are
sir.
thinking.
Sir,
Hmm.
no, sir. Like
Can
if there's
I
a
ask?
black hole which is
Hmm.
smaller than the sun, like can the black hole suck the sun?
No, black hole cannot be smaller than sun because there is a limit, minimum mass you need to form a black hole. Okay, and that limit was discovered by Chandrasekhar. He was an Indian scientist, right? And he got, I think, Nobel Prize later for his, and it's called Chandrasekhar limit. So that is, he said like you need minimum mass to form black holes. Okay. So yes, sun or smaller than sun, you cannot form black holes.
Sir, I have another question. Like
Hmm.
how long can a black hole last? Like how much can a black hole
Uh,
last?
Forever. Black holes can last forever. There is no end
Yes.
to it. So they can last as long as they have energy. Because it's like a mass. Okay. For example, Earth will last forever unless something
Sir.
hits us or sun consumes us or anything happens to us, right? So it's a mass. It's just floating around.
Okay, sir. Sir, I have the
Okay.
last question.
Quickly.
How much time does it
Okay.
take for
Wait, everyone just mute yourself. Just mute yourself, everyone. Okay. Next one is the Hasini. Hasini, do you have any doubt? Please ask your doubt.
Sir, on the first class of this thing, one ma'am told that like
Hmm.
the earth revolutes the sun because of the earth's gravity. But then in my school I learned that the earth's orbit is elliptical. If it's
Yes.
orbiting because of gravity, how is it supposed to be elliptical, sir?
Simple because nothing is perfect, right? So to have a circular orbit, it has to be perfectly aligned with everything, right? Circle is a perfect ellipse actually, right? Once eccentricity becomes zero, it's a circle. So circle is a special case. So it's always going to be ellipse because if you look at the sun and the earth, they are not like perfect sphere. Even sun is not a perfect sphere. Earth is also not a perfect sphere. So the gravity is not exactly the same all around the globe, right? For earth also, for sun also. It's slightly more and less. So because of that, the orbit becomes slightly elliptical, right?
Okay, sir.
Okay, so it's not perfect. That's all.
Okay, sir.
Okay.
Somebody was okay. So
Yes.
one question I'll answer because somebody asked it that what happens if black holes merge or they hit each other. Nothing happens. Means, yeah, of course, a lot of things happen. It's simply like two big objects, they collide, lot of energy is released, and where that energy is released in form of gravitational waves. And recently in 2015, I think it was first detected, first time by LIGO mission. So you can read more about it. It's LIGO mission. I'll type it here. So LIGO mission has detected these gravitational waves for the first time, which is energy released by the collision of two black holes. Okay, please go ahead. Who's
Yeah,
next?
Kaveen Kesav. Hello,
Hmm.
Kaveen. Stop doing anything and ask your doubt.
Sir,
Say hi.
is white hole and black hole are made like black hole are made different and white hole are made in different forms. So how do white hole form, sir?
What?
White holes. It is the opposite of black hole.
See, these things are just theoretical regions. Like it's like when we say electron, so we have a positron, right? It's an exact
You speak,
opposite of the
we
electron.
can't hear you
Sir,
clearly.
Your
there is some
voice is
issue.
breaking.
Yeah,
You're
everyone,
not
just
Hear
calm
you.
down.
Relax,
Yeah,
relax. If my
just,
voice
just
is
calm
breaking,
down,
relax.
everyone.
Yeah, relax. I'll say again. Is it clear now?
Yes,
Yes, sir,
sir.
it's clear.
Okay. So what I was saying, white hole is a theoretical concept which says it acts opposite to black hole. That means if nothing can escape black hole, so white hole is like nothing can enter white hole. Okay. So it's like a fountain. All right. So it's pushing material so fast out that nothing can enter it. All right. So the thing is, the white hole is a hypothetical concept. There is no like actual white hole which exists. These are theoretical concepts which people think should exist and to compensate for black holes, something like that. Okay.
Okay, sir.
So black
Okay.
holes have been detected by gravity measurements because the gravity changes significantly around black holes. Of course, you cannot see them because nothing comes out. But
Really?
since there is gravitational effect by these black holes, so you can see the gravitational impact of these black holes.
Okay. Thank you, sir.
Okay, next.
Okay.
So, sir,
Maitri, please ask your doubt.
Sir,
Yeah, everyone is going to get the chance, please.
Hmm.
sir,
sir,
Maitri,
Hmm.
please.
yeah.
sir, I have a doubt. Sir, I have a doubt, sir.
Yes, please go ahead.
Sir, I've heard of the parts of black holes like quarks, sir, but I haven't heard about the others. How many parts are there, and can you name them, sir?
Where in the black hole?
Yeah.
See, there are no parts. Black hole is just a body. You guys have to understand. It's a big body. That's all.
Sir,
Earth
I can't
is
hear you, sir.
Your voice is
huh?
cutting. Your voice is
Okay.
breaking.
Yes, sir.
Okay. Again,
Sir,
I was saying. Okay, I was saying.
Sir, please unmute yourself.
Yes.
Everyone just mute yourself. Sir, yeah, please continue.
Okay. What I was saying is, a black hole is just a big, massive body. It has no parts. Like we have Earth. There are no parts of Earth, right? Of course, we have some layers inside it, but other than that, Earth is just a big body, right? So black holes also are just bigger bodies. They don't have parts or anything like that. To study them, yes, we define few things related to black holes, like event horizon, like beyond which we cannot see anything. And then if anything falls into event horizon, then it is not going to come back out of black hole. So those things we just define for our understanding. There are no parts of black holes. Okay. Okay, next.
Okay. Next one is let me ask.
Sir,
Yeah, Sebastian Anthony.
sir.
Sebastian, if you everyone, please
Sir,
wait a second.
please.
I don't have
Okay.
a pen.
Please.
Sebastian, ask your doubt.
Please, sir.
Uh, Okay, sir. Who is Atharva? Atharva, please ask your.
So,
Sir, I
sir,
have a doubt.
Atharva, please ask your out.
yes, sir,
Atharva.
Yes.
yes. So, my doubt is, sir, you know how the what I call this Goldilocks what was that Goldilocks?
Goldilocks zone, yes.
Yes. So my doubt was that will so you're
What's
saying that
Goldie?
beyond maybe we'll see some life forms or some other planets that are livable.
Hmm. Yeah, there's a possibility if we can find planets similar to Earth, there is a possibility we might find some form of life there. Maybe not like our Earth, but maybe some form of life, like microbial life, maybe some small single cellular organisms like we have on Earth, microorganism, things like that. Okay, so it's a possibility.
Yes.
Yeah,
Uh,
Sarvesh. Sarvesh, ask your.
Sir.
Sir.
Yeah, everyone. Please wait a second. Yeah, Sarvesh.
Nobody, did we discover the Goldilocks zone? Like, where we went in the Goldilocks zone?
yes, so we know about lot of Goldilocks zones around many other stars, but we have not found any planet with any form of life yet. So we are trying. People are
So,
trying.
but you say like aliens are there, like they're not
I I
aliens.
I never said aliens are there. Okay, I'll put the link here.
Okay.
This is the link of that video, so you can watch it. Maybe I can pin it if possible. No, it's not possible to pin it. Anyway, so this is the YouTube link. You all can save this link and watch it later. Okay, people are just typing. So
Okay, sir.
so there I have discussed like if we will find aliens, what kind of possible scenarios are there where we can find aliens? That's all we have discussed.
Okay, so
Can I ask
Okay.
my doubt
Yeah,
now?
Sivans. Sivans, please ask your.
Sir, you call me for this survey, so can I ask
Sir,
one?
Pluto is a dwarf planet, right? So is there any life on it?
This is just absolute chaos.
So
Uh, Sivans, could you please repeat your question?
Sir, Pluto is a dwarf planet, right?
yes,
So does it have any chance to have life on it?
no, because the problem is it is very far away from sun, so everything is frozen like ice. So there is no possibility
Sir,
to
your
have.
voice is breaking, sir.
Okay. So what I was saying is, okay, everyone please mute so that I can speak. Otherwise, it will be like this only. Okay. So what I was saying that Pluto is a dwarf planet, but it is very, very far away from sun. So it is very, very cold. And because of that, it's all frozen ice. Okay. So because of that, there is no possibility of having any life form there. You have to have some slightly higher temperatures to for any life to sustain.
And sir, does
Hmm.
the planets get bigger for any number of years?
What planet?
Does the planets get like in size bigger in
Mm-hmm.
any number of years?
Planet used to when
Your
universe was
voice is
forming.
breaking again.
Okay, so
Can I ask a question?
okay,
Sir, I,
somebody asked like if
Excuse me, sir.
planets gets bigger, right?
I
So
have a
yes,
question.
Hello.
Excuse
yes,
me, sir.
yes,
So
planets
can you
get
repeat, sir?
bigger if they capture more material from.
uh,
So
sir,
yeah,
yeah,
yes,
please
yes,
speak, sir.
I get it. Yeah. So if planets capture more material from the space, they get bigger. But currently, it is not happening in our solar system because our solar system is fully in its final state. When our solar system was forming, then small chunks they combined together and found bigger and bigger planets. So that's how they become bigger by capturing the material from the space. All right. Next.
Uh, if you're having any doubt, sir, if I'm allowing them, they're just speaking everyone just listen carefully. Just have some proper way. Just raise your hand only. Everyone just going to get the chance. If you'll just do it
Yes.
like if someone just asking any question, just hear them properly. If you'll speak in between as well, we are just going to end the session here only. No one just going to be able to ask any doubt. Or I'm just going to read out the question from the chats. So you won't be able to talk. So just
So
try to
chat
understand. Just ask your
would
doubt one by one. Okay?
spam the chat. Everybody is just typing their question one after another.
Yeah,
So
yeah.
please
And just
stop.
stop spamming this much. If you're having a
Yes.
legit doubt, just ask your legit, like the proper doubt.
Yeah. Otherwise, I won't be able to
So,
explain anything.
so someone is having like suppose a supermassive black hole and a small stellar mass black hole come close enough for gravity to pull them together. What happens during their collision and eventual merger? What's gonna happen after that? What does the Einstein theory of general? Okay, so basically they are asking if there is a two black hole, a stellar and the supermassive. So what's gonna happen if both
I
are just
think
going to
I've
collide?
just answered this question. If two big masses like black holes or anything they come together, they will just collide with each other. Currently, a lot of black holes they collide with each other. Even galaxies they collide with each other. We have big stars colliding with each other, and whenever that happens, lot of energy is released. That's all. As simple as that. Because once the collision will happen, some mass will be converted to energy. Einstein equation E equals to mc square. So mass is converted into energy, and that energy is released in the space. If we can detect it in form of gravitational waves, yes, sometimes we do, sometimes we can't because the energy is very faint. Okay, next.
There is someone having question like there any relation between nebula, star, and black holes?
See, first a nebula is there, then stars are formed, and then from stars, if they are big enough, they will collapse and form black hole. That's all. Can black hole die? No, there is almost impossible for a black hole to die because there is nothing to die. It's as I said, it's an object. It's an object. How can object die? Nothing dies because all the star's energy was gone, and then it formed black hole. And black hole is so huge, it's just consuming material, and that's all. So it's going to stay there forever. Okay.
There is one more question from Isan. What is dark energy and why is it pushing the universe apart?
Okay. Nobody knows what dark energy is. Nobody. Even the best experts in that field, they don't understand dark energy and dark matter properly. And that's why it's called dark energy and dark matter, because we see its effect, but we can't uh, actually see it. So black hole is different. Don't mix these two things. Black hole, we actually see the impact, and we have imaged the black hole like surrounding and everything, and we know what happens around black hole and all these things. So black hole is just like it doesn't appear because light cannot come out of it. So that's a different thing. But dark energy and dark matter, they have significant impact. Like they expand our universe, they have effects, a lot of effects like gravitational effects. But we cannot detect them using any of our current technology. So that's why it's dark. All right. So I don't know much about it. Nobody knows basically. Even if you Google, you won't find much answer about it. So very little is known about it. Some research is being done, but yes, very little is known about it.
There is another question from the
Hmm.
Kuntalagiri, and he is asking, is there any other black hole in our galaxy? First question. Second one is, how big the Milky Way galaxy is? Third one is there any other Goldilocks zone existing in our Milky Way galaxy
Okay.
besides solar system?
Okay, very quickly, I'll tell you. So our Milky Way galaxy, at the center, we have a very supermassive black hole, and that is what keeping the galaxy together. All the stars, solar system, everything is going around the galaxy because of that supermassive black hole. Like our sun is there in our solar system, everything is going around. So in our galaxy, the black hole is there and everything is going around. So that is there. There are billions of solar system within our galaxy. So yes, within those solar systems, we have Goldilocks zones, but we have not detected any form of life form yet. If you want to know, I can think of one name. It's called TRAPPIST system, TRAPPIST. So it's a
Yes.
star called TRAPPIST, and around it, many Many planets are there, so it's called TRAPPIST system, and there we have detected planets which are very similar to Earth, and yeah, so we have Goldilocks zones in that solar system. Okay.
Sir, someone is having a kind of interesting doubt. How we are
Mhm.
being able to measure the speed of light and how we are being able to calculate the light year.
Speed of light, there are many, many experiments. If you have not read it, don't worry. By class 12th, you will learn all these things. There have been many, many experiments done by many people. So basically, you pass light through some system and you slow it down, and then you just measure the time it takes, and then you get the velocity. So that's how speed of light is measured. And it has been measured like hundreds of years ago, like in 1900s, people have measured it. Okay. There are many experiments to measure speed of light. So that is one thing. So once we know speed of light, as I mentioned earlier, it is 3 into 10 power 8 meters per second. So once we know speed, you just multiply it with time. So in this case, the time is 1 year. So 1 year is 365 days, right? And then 365 you multiply by 24 becomes hours. Then you multiply by 60, it becomes minutes. And then multiply by 60, it becomes seconds. So that many seconds you have in 1 year. And then seconds you multiply with the speed of light. So time multiplied by speed is distance, right? So that is your light year. That distance is your light year. That's how we measure it.
Okay. Sir, there is a very big misconception, like how people think that the
Mhm.
Big Bang is basically just like a vacuum cleaner, and if there is a black hole, maybe somewhere, it's just going to suck everything around you. Maybe you are, it doesn't matter how far you are. I think there is a lots of question related to that only. Like what gonna happen if any satellite is going to suck into the black hole? There is a lots of questions regarding that only. So
Yeah, black holes very interesting objects in our universe, and people want to know about it. I understand it. See, knowledge, as I said earlier, also, our knowledge about universe and black holes, all these things are very, very limited. Why? Because we are very far away from these things, right? So, measuring anything or getting information about anything from such large distance is very difficult. First, the signal is very faint signal is there, and then detecting it with all the complicated these telescopes and all is also very challenging. So yes, the knowledge is very limited. Now you have these questions like what will happen this if that happens, that happens. See, if something gets very close to a black hole, it is going to get sucked in. It's as simple as like we have Earth, right? And we send rockets. But if there is a problem with a rocket, right? If we won't be able to give enough push, what will happen? It will not go into the orbit and it will be sucked by Earth and it will fall on Earth, right? So same thing. If any object or anything gets too close to a black hole, it will get sucked into it, and that's all. And if you send a lot of material, the black hole will become bigger and bigger with more and more material. And when it becomes bigger, the gravity will be even higher. So because of that, the distance which you can get close will become even further and further away. Because, for example, for Earth, if you just come, let's say, X kilometer close, and you will get sucked in. Otherwise, you can just float around. But for Sun, you cannot even get X kilometer. It will be it will be more than X kilometer, right? You have to be very, very far away from Sun. But otherwise, Sun will pull you in, right? So that's what with black hole also. It's just like that. Simple, another object. Don't think there is like something like suddenly something will happen. No, it's just another object, but with extreme properties. That's all. Okay?
there is a next question is
Hmm.
like, is time travel possible?
Hmm. Time travel. If you understand, like time travel is a very complex thing, and there are a lot of things which are associated with it. And I'll give you a very simple understanding of it. Time travel is not what you think. And again, if you want to go into very complex discussion, I have another video on it. So you can watch it. Okay, now people start spanning. Let me finish. So
Sir, you can just send me the link.
I'll send you the links later. Okay. So the thing is, with time travel, time and space are connected, right? So space and time are not different. So the way we perceive time is just an illusion. There is no such thing as time. It's just passage, right? So space and time are connected. For example, if you go back, let's say if you can travel in time, and I go back a day. If you just go back one day, what will happen? The problem is you won't even land on Earth because Earth was not here a day before, right? Earth is going around Sun. So one day before, Earth was not here. Earth was one day behind in the orbit, right? So if you just go one day back, you will be in space floating, right? So space and times are so interconnected that traveling in time is impossible as far as we know or we understand our universe, that time travel is nearly impossible. Yes, you can travel in future if, so it's a big if the speed which you travel with is very very high. Very high means if you travel with the speed which are very close to the speed of light, then you will travel so fast that you will start traveling in time and you will reach in future. Okay, so because then the time you will perceive will be much slower as compared to others. So they will get very old, but you won't get old, and you will remain very young, and then you will travel very many years. So let's say you will grow 10 years, then the people on earth will grow, let's say, 40 years or 50 years. So you are basically traveling in future. But yeah, going back, no, you cannot do it. No matter how fast you travel, you cannot go back. As far as our universe is concerned, or our knowledge or understanding of the universe is concerned, time travel like that you see in movies or these things is not possible because you cannot disconnect space and time. So as simple as that. All right.
There is a one more question the people just going to like asking. There is a one guy who's just spamming.
Mhm.
That is multiverse possible? Multiverse. And what is the age of our universe and what is the outside of our universe? Something like that.
Okay, so age of our universe, we have already calculated it with high precision. It's about
Like edge
3.6.
is of it, like the corner or any other
Okay,
boundary of
the
our
actual,
universe.
okay, actual edge we don't know, and we will never know because our universe is expanding. Okay, and it is expanding at a very fast pace. So something which is very, very far away from us, the light emitted by that object is never going to reach us. So we will never be able to detect it because it is so far away and expanding so fast that, and again, the dark energy and dark matter is responsible for it. So dark energy is basically responsible. Energy is what drives things, right? Matter is what matter is. So it just occupies space. So because of that, we will never know what actual edge of our universe is. We can only know the edge of the observable universe. So observable universe is the universe up to the point which we can observe. So up to that point, the energy or the light can reach us, reach Earth. Beyond that, it will never reach us. So we will never know what is beyond that. And that's the multiverse. Maybe it is possible. I don't know. And maybe that is the reason dark matter exists, and that might be the another universe. And as there are multiple universe, we are not allowed to cross that boundary because otherwise, if one can go from one universe to another, it will break those universe and the laws of universe. So laws of physics will be broken, and because of that, probably the multiverse do exist, but we are not allowed to cross that boundary, and therefore we are not able to observe them properly. Okay. So yes, multiverse can exist.
There is a one more question, sir. I think it's nice question. After that, we can end this here only. Sir, if the universe is expanding, then why Andromeda
Hmm.
galaxy is like going to collide with Milky Way galaxy?
Okay. Don't mix things. Okay. That is the one problem I see with many students is like you mix things here and there. So one thing is expansion. So expansion of universe is as a whole universe is expanding. So for example, okay, let's say some example, not talk about universe. Like if I say your body. So if I'm walking, okay, I might stretch my hand a little bit like this. So my hand is stretched, right? My muscles do get stretched. So does it mean the blood inside it is also getting stretched? No, not every molecule in my body is getting stretched, right? Let's say we are walking. So our legs will go far away from each other. But that does not mean that and everything inside our body is also moving far away from each other, right? So universe expanding is like that. It is expanding means the whole universe is expanding because of the Big Bang explosion which happened. The remaining energy is still there, so it is pushing the universe away due to that explosion and all that. Now, because that is happening within the system, there are objects which are interacting with each other. So, if let's say there is an object, there is another object, they get too close to each other while the expansion is happening, right? They might collide with each other. There is nothing wrong in it. Like as I said, within our body, there are multiple molecules. They can hit each other. Some organ can interact with other organ. Some parts can, but everything will stay inside the body. So that's how universe also works. So that's what it is, I guess.
Okay, sir. So I think that's all about today. It's been 1 hour, by the way. Uh,
Mm.
there's a lots
I-
of question with mix up with the spam, but overall these were the doubts. Overall, the time
Mm.
travel, black hole, multiverse. So yeah, these are the type of doubts.
Yeah, I think I have answered many questions, but I see still a
Yeah.
lot of hands are there.
Yes.
Okay, well, one thing I'll do, I'll take two more questions, but only if they are not connected to what I have already answered. So if you have any question, you tell me and don't type in the chat. I'm not going to read the chat. It's like a spam. It's not possible to read it. And if it's a GK question, please don't ask me because GK question, you can just Google it. Like what is the nearest star, what is the nearest galaxy, all these things, right? So please, if you have any question which is very different than what we have discussed so far, please do ask me.
One question like spamming, but yeah, it's kind of good.
If it
Uh,
is going microwave life on another
like
planet,
sun is white, but it is having color of the earth as well, and it is showing the different colors on the on planets and all. It's
hmm.
easy for you.
No, so what is the question?
The
Like,
question is why sun is white. This is the point.
like why different colors?
Why sun is white?
Why sun is, oh, okay, very
Mm.
interesting. Yes, that's a
Yeah.
good question.
Yeah.
So sun is white because of the temperature of the sun. As simple as that. If so in case you don't know, the temperature of sun is approximately 6,000 kelvins. The surface temperature, of course, inside it's higher, but anyway. So surface temperature is 6,000 Kelvin. So if you have 6,000 Kelvin object, even if it's not sun, any object, if you can heat it and raise the temperature to 6,000 Kelvin, it will start appearing white because it emits the visible light which we can see and in a certain combination, so it appears white. If you have an object, excuse me, if you have an object which has higher temperature than the sun, so let's say more than 6,000, let's say 10,000 Kelvin, 20,000 Kelvin, then that object will appear more blue because as you make the temperature higher, the objects will appear more and more blue. And if the temperature is lower, let's say 4,000 Kelvin, 3,000 Kelvin, then the object will appear more red. Okay, so that's why how object colors are there. So our sun just appears white because the temperature is perfectly 6,000 kelvins. If it is higher than that, I'm not saying 6,001. There's a range. Okay, so within that 6,000 range, it's white. Very high, higher than 6,000, it will be more blue, and lower than 6,000, it will be more red. And if the temperature goes, let's say, very high, then it won't be even visible to us because that then it will be start radiating mostly in X-rays and gamma rays, and then we won't be able to see it, right? And if the temperature goes very low, then also we won't be able to see it because then the radiation will be in like near infrared or microwave, and then we won't be able to see it. So that's what the colors are all about. I guess that was a very interesting question. Thank you. Wormholes, we have not detected any so far. Asteroid mining, in case you are asking, we have not done it yet, but people are planning to do it. Yes, we will get a lot of interesting material from that. Big Bang, yes, it happened as far as we understand the universe, but we don't know what happened before that. There's no way of knowing it because everything started with Big Bang. So there, what was before that, we don't know. Uh, okay. Uh, Anything? Okay, I cannot read the chat the way it is happening. So
Yeah.
I guess we will stop here. Thank you.
Yeah. We'll end this session
Singularity,
here only.
okay. I'll just tell you what singularity is. Uh, Saying unmute, I'm not muted. So singularity is simply the places where the equation of physics and mathematics fail. For example, the center of black hole. That is where the Einstein equation also fails. And fails means the pressure and the conditions are so high, or the gravity is so high, that we don't know how to express it in terms of equations. That's all. Okay, thank you. I think we'll end there.
Okay. Okay,
Yeah.
sir. Thank you so much for joining us today. And okay, everyone. So recording will be available on your Google Meet, Google Classroom. So okay, bye. Bye, everyone. Bye, sir.
Okay,
Thank you so
still
much, sir.
videos, you guys will have it later. Okay.
Yeah. Okay. Okay, sir.
Okay.
Okay.
Thank you so much. I'll also disconnect.
Okay. Okay, sir. Bye. Bye, everyone.